Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Solving simultaneous equations with three variables, in this case x, y, z. This is an example of a question that was on the 2013 sample paper that was brought out when Project Maths came about first. Just have a quick look at the equations before we start. You can see that it has three variables, x, y, z, all written in the same format. That's important, the x's over the x's, the y's over the y's, and the z's over the z's. That's important so that we get signs right. Okay, so just like in Junior Cert, we're going to cancel one of the letters and we're going to solve for the rest. Okay, but how do you handle it when it has three equations? The first thing I'm going to do is just call the equations 1, 2, 3, and that's just for convenience. Okay, I take two equations at the start. Any two, it doesn't really matter which ones. So when I look down these, I'm trying to decide, will I cancel the x's, the y's, or the z's? Z's look okay, 3, 2 and 1. I could bring these two up to 6. Or I could take equation 1 and 3 and bring these up to 3. However, when I look at the z's, I have the x's, I have 2x, 2x and 2x. So x's look like a handy one to cancel. So take any two equations. I'm going to take 1 and 2 here. 2x plus 8y minus 3z is equal to minus 1, 2x minus 3y plus 2z being equal to 2. Put a line under them and I'm adding them. Okay, now if I add them as is, you can see that I'll get 2x plus 2x will give me 4x. So they don't cancel. So I have to change the sign all the way across, and you can see I put my new signs into a circle in a different color so that I know that that's my new sign and that's the sign I have to take. Now 2x minus 2x cancels. 8y plus 3y is 11y. Minus 3z minus 2 more z's is minus 5z. Minus 1 minus 2 is minus 3. Okay, this becomes my equation 4. I can't do anything with it right now. I just park it. I can't do anything because it still has two variables, y and z, and I can't solve an equation for as long as it has two unknowns. Right, the next step is you must use equation 3. So if you notice, I've done 1 and 2 here. I haven't used 3, so I must use 3 in this one. And I can choose any one of the other two, whichever you like the look of. And it doesn't really matter in this case because all of the x terms are 2x's. So it's a direct cancel, so it's not too bad. I don't have to multiply each equation by anything. So I'm taking 3 and 1 here. So I'm just writing them down. And then 3 is 2x plus y plus z is equal to 5. And you can see I've been quite strict keeping the x's over the x's, y's over the y's, and z's over the z's. And that's just to make it more easier for me to see what I'm doing. It's not for anybody else. Okay, 2x minus 2x cancels. I get plus 8y minus 1y, so 8 take away 1 is 7y. Minus 3 minus 1z. Minus 4z, if there's never a number in front of a letter, it's always a 1. Minus 1 minus 5 gives me minus 6. And I'm going to call him equation 5. Okay? So now what's the next step? Well, the next step now is I bring these two together. So this starts to resemble more like a Junior Cert one now, where it has two variables. This is 4 and 5 that I'm bringing together, and then 7y minus 4z being equal to minus 6. Okay, so a couple of things to note here now before I continue. Notice that when I took 1 and 2 up here, and when I took 3 and 1 here, in both cases I cancelled the x's. That's not a coincidence. You must do that. You must cancel the same letter in both sets of equations that you take. And the reason that you do that is when you cancel the x's in both, you're left with y's and z's. So if you look at my equation 4 and 5 here now that I'm bringing together, you can see I've just y's and z's. Okay, and now I'm going to do simultaneous equations again, and I'm going to cancel one of those letters. If up here you had, for example, cancelled the z's in this one, then you would have been left with x's and y's. So you'd have had x's and y's in your equation 5, you would have had y and z's in your equation 4, and so between the two of them you'd still have x, y, z. So you were actually no better off in that case. So rule 1, you must cancel the same letter in both pairs of equations. Okay, so just like before now, I'm looking at these, and again I can cancel either letter. I can cancel the y's or the z's. It doesn't really matter. There's none of them is an easy cancel. Let's cancel the z's. Okay, so how do I do that? I can see that lowest common multiple of 5 and 4 would be 20. So if I multiply the top one by 4, it'll bring those z's up to 20. And if I multiply the bottom one by 5, it will bring that equation up to 20. So let's do that. Let's do it here. So I get 44y minus 20z being equal to minus 12. 5 sevens, 35y minus 20z being equal to minus 30. Okay, line under it. Can I cancel the z's at this point in time? No. If I cancel them right now, I'll get minus 20 minus 20, giving me minus 40. So that's not going to work. So let's change the sign, change the sign, change the sign. So 44 minus 35 is 9y, minus 12 plus 30, and you can always do your sums, read it the other way, so it's 30 minus 12 is 18. Divide both sides by the number in front of y. Y is equal to 2. And that's my first part of the answer, y is equal to 2. Okay, am I done yet? No, because you have to solve the simultaneous equations, which means solve for every letter, x, y, z. So I only have y for now. So now let's find the next letter. Okay, so we sub it back in. So I'm going to sub y is equal to 2 into, now which equation? Can I go back to equation 1, 2, 3? No, because if I go y is equal to 2 up here, I'll still have two unknowns, x and z. So for as long as you'll have two unknowns, you can't solve them. So what you do is you go back to either 4 or 5, because in each of them you've only two unknowns. You know one of them, you know the y's, so then you'll be able to solve it for the z. And then the theory is when you have the y and the z solved, then you go back to 1, 2, 3 and find the x. So whether it's 4 or 5 we sub it into, it doesn't really matter. Let's sub it into 4. So I have 11y minus 5z being equal to minus 3. Sub in the y being 2, so that I have 11 by 2 minus 5z being equal to minus 3. 11 2s are 22 minus 5z is equal to minus 3 minus 22 minus 5z is equal to minus 25. Divide both sides by the number in front of z. Z is equal to 5. Okay, so now I have my y, now I have my z. Okay, so I can go to either 1 or 2 or 3 and sub in my y and my z and find the first letter that I cancelled, which was the x's. Okay, I'm going to sub it into 3 because it looks nice and easy. I have single y, single z. So now sub into equation 3, okay, which was 2x being plus y plus z being equal to 5. 2x, my y is 2, my z is 5 being equal to 5. 2x plus 7 is equal to 5. Bring him over. 2x is equal to 5 minus 7. 2x is equal to minus 2, divide by the number in front of x is equal to minus 1. So the solution, y is equal to 2, z is equal to 5, x is equal to minus 1. Okay, I have boxed my answers, you may notice that. That is to direct the corrector of my leaving cert to the answers. Okay, don't have them trawling through your work trying to find your answers. Make it really easy for them, and in that way they'll see that you've all the letters and it'll be a quick correct. You don't want them running the risk of missing some of your hard work. If you're enjoying this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision and virtual and augmented reality. You'll need a H4 in maths to qualify for this program. Check out the link below for more information.